From Kitty Hawk to Cape Kennedy. NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
The flight of McDivitt and White in Gemini 4 and the 8 days of Gemini 5 with Cooper and Conrad were considered long-duration missions. This is astronaut Frank Borman, command pilot for Gemini 7, the third and final long-duration flight, one which could last as long as 2 weeks in space. Borman has been training for this mission for 3 years. The second member of the Gemini 7 team will be James A. Lovell. Until his piloting assignment, astronaut Lovell was responsible for monitoring the design of spacesuits and developing techniques for lunar and Earth landings and recovery. Here, the two men prepare to rehearse getting out of Gemini at sea. When they actually fly the long orbital mission, extensive medical data will be gathered. Included are experiments on the effects of weightlessness, in-flight sleep analysis, and many more. One of the other experiments calls for the men to take pictures of storms and cloud cover over the same areas photographed by NASA's Tyros weather satellite. These will then be given to the Weather Bureau for comparison. When it is completed, Gemini 7 will be the longest flight ever achieved, an important milestone in this country's exploration of space. For over 50 years, NASA and its predecessor, the National Advisory Committee for Aeronautics, have performed much of the aeronautical research in the United States. The birth of new concepts as a result of theory must be followed by extensive full-scale tests. NASA's Flight Research Center, located at Edwards, California, was established in 1947 for this purpose. One of the center's major programs is the X-15. The X-15 is a research aircraft being used to gather information about man and materials at high-speed, high-altitude flight. The data from this research program will help build the airplanes and space vehicles of the future. In addition to the normal aerodynamic research, studies are underway for the design of a supersonic transport. In cooperation with the Air Force, flight engineers at Edwards have installed new instrumentation into the giant XB-70. The 185-foot-long plane is designed to fly at 2,000 miles per hour, 3 times the speed of sound. Many of the research craft which have been flown only on paper and in wind tunnels are actually flown at Edwards. This one, called the M2 lifting body, has no wings at all. The body of the craft is shaped in such a way that it doesn't need wings. Right now, a vehicle returning from space must be recovered from the ocean or drift down on land by parachute. But scientists are trying to design a craft which can fly a space mission, return through the Earth's atmosphere, and then land like an airplane. It is toward this end that NASA is studying lifting bodies. This test pilot is climbing into another machine, a machine which is helping prepare men to land on the moon. Called the Lunar Landing Research Vehicle, it can duplicate many of the features of a lunar craft, including 1/6 gravity. Both the piloting and operational procedures of manned lunar landings are being studied. Whether flying to the fringes of the Earth's atmosphere, paving the way for a supersonic transport, studying spacecraft that can fly like a plane, or solving the problems of landing on the moon, the flight research of today will affect our air and space travel of tomorrow.
This has been an Aeronautics and Space Report, presented by NASA, the National Aeronautics and Space Administration.